Hi, Vencore weather meteorologist Paul Dorian here. Well, it's that time of the year again where we like to take a look at some of the factors that can play an important role in the upcoming winter season in the Mid-Atlantic region and across the nation as a whole. Last winter, of course, was quite a notable winter with colder than normal temperatures throughout much of the eastern two-thirds of the nation. Many areas experienced above normal snowfall, including right here in the Mid-Atlantic region. The focus of the greatest temperature departure from normal last winter was across the Great Lakes region, the upper part of the Midwest. The Great Lakes experienced some record ice cover not seen in many, many decades. Some of the factors that played a role last winter continue this winter, but there are some new factors. Anytime I deal with seasonal forecasts or medium or longer term forecasts, first thing I like to take a look at is the sea surface temperatures across the oceans around the world. The biggest ocean, of course, is the Pacific Ocean, and the Pacific Ocean sea surface temperature anomalies can play a vital role in the winter season that can be expected in the eastern part of the U.S. Well, let's start off by looking at the very latest sea surface temperature anomalies across the world. Again, oceans are crucially important whenever dealing with a seasonal forecast or longer range forecasting. The oceans contain 1,000 times the heating capacity as compared with the atmosphere, and what goes on in the Pacific Ocean is crucially important to the U.S. in an area where westerly winds bring Pacific Ocean air into the U.S. It is crucially important to take a look at and see what's going on in the Pacific. I want to focus in on two areas. All the yellows and oranges right here represent above normal sea surface temperatures for this time of the year, and there's this area tucked in along the Alaskan southern coastline that really is not a new feature. It was there all of last winter and for the last many, many months. This feature here, this warmer than normal pocket of water just south of Alaska, was there last winter, and it will play an important role over the upcoming winter. A new feature this year, however, is down here across the equatorial region of the tropical Pacific. This line right here, it represents where the equator is, and notice all these yellows and oranges representing above normal sea surface temperatures. This indeed is a weak El Nino that has developed over the last few months. Notice the focus of the greatest temperature departure from normal right now is across the just off the west coast of South America. I believe this area of the greatest temperature departure from normal will have to actually shift over the next few weeks, couple of months into the central Pacific. This should ultimately become a centrally based El Nino, a weak to moderate El Nino. I do not believe it will develop into a super strong El Nino. It's important to determine whether or not there will be an El Nino when you're dealing with a winter forecast in the eastern U.S., but not only is weather a El Nino will form important, but the magnitude is important and exact location of where the greatest temperature departures from normal. In other words, a centrally based El Nino has a different impact on temperatures across the eastern U.S. as compared with eastern based El Nino. And again, I believe, and computer forecast models back this up, that this will ultimately become a centrally based weak to moderate El Nino, and that combined with the northern pocket of warmer waters in the northern Pacific will play an important role in the winter weather season coming up here shortly. Well, one model that NOAA produces called the CFS, Climate Forecast System version 2 model, has a depiction of the Pacific sea surface temperatures right here for January, February, and March that I'd like to focus in on. And sure enough, it has this warmer than normal pocket tucked in along the Alaskan southern coast here, represented here by the oranges. And notice here across the equator, this is the equator latitude right here, the El Nino pattern as forecasted by the CFS version 2 model. It has the center, the greatest departure from normals of temperature out here in the central part of the tropical Pacific, as opposed to where it currently exists along the west coast. So this is one model that supports the theory of a warm pocket of water in the northern Pacific and a centrally based weak to moderate El Nino during the upcoming winter season. Again, this is the January, February, March time frame here. Now the question is, what is the result of this kind of a sea surface temperature pattern with the warmer waters in the North Pacific and a centrally based El Nino? What this typically leads to is a trough out here in this part of the Pacific, then upper level ridging across the west coast of North America, and then a trough again in the eastern U.S. And what this does is it allows for the movement of cold air masses from northern Canada right into the northern part of the U.S. So again, this type of sea surface temperature pattern in the Pacific Ocean will tend to lead to a cold and potentially snowy winter in the central and eastern U.S. with upper level ridging often seen in the subsequent wintertime season. Well, here's another model that backs up that theory of a centrally based El Nino with the northern pocket in the northern Pacific of warmer than normal waters. This is from the Japanese Meteorological Agency. It's a model called the JAMSTEC, and this is the winter forecast, December, January, February time frame for 2014-2015. Again, here we go. The same kind of a pattern with a warm pocket tucked in along the Alaskan coast and a centrally based weak to moderate El Nino with the greatest temperature departures from normal out here in the central part of the tropical Pacific as compared to along the South America west coast. So a couple different models give us high confidence that this ultimately will be the type of pattern that occurs during the January-February time frame in the Pacific Ocean, and that in turn favors ridging along the west coast and a colder pattern in the eastern part of the U.S., potentially leading to above normal snowfall. Well, one of the next things I wanted to do to prepare for this winter outlook was take a look at some past winters that had the same kind of a Pacific Ocean sea surface temperature anomaly pattern. So the first thing I did was I took a look at some of the coldest winters going back about 60 years, all the way back to the 1950s. You see these years down here. There's typically a few winters every decade. In the 70s, for example, 76, 77, 77, 78. In the 80s, 83, 84, 84, 85, and all the way back to last year, which is considered a cold winter. Indeed, it was. And this is the air temperature anomaly pattern for all of these cold winters on average. And as you can see, basically the eastern two-thirds of the nation much colder than normal, as represented here by the purples and blues, and maybe some warmer than normal conditions out in the western third of the nation. So these are the winters I wanted to take a look at. Again, the coldest winters going back 60 years or so. Well, let's take a look now at what kind of sea surface temperature anomaly pattern the coldest of winters going back to the 1950s, featured. And sure enough, look at this. A warm pocket right here tucked in along the Alaskan coastline, and a centrally based El Nino type of pattern right across the equator in the tropical Pacific. Unbelievably similar to what is forecast and what I have high confidence in believing will occur this winter. The same kind of a sea surface temperature anomaly pattern across the Pacific Ocean expected this winter, similar to the coldest of the winters when we averaged them together going back to the 1950s. And indeed, this is a better way to look at this comparison. On the left here, we have the CFS version 2 forecast for the sea surface temperatures for the January-February time frame. Again, notice warm pocket here, northern Pacific, centrally based El Nino. And this is the actual pattern that occurred during the coldest of winters, about 15 winters going back to the 1950s. Warm pocket tucked in right here in the just to the south of Alaska, and a centrally based El Nino. Not only is the Pacific Ocean similar, but take a look here. We have a cold pocket in the forecast for this winter out here in the middle part of the Atlantic, similar to what happened during those winters going back to the 1950s, and kind of a cold pocket out here in the west central part of the Pacific, similar to what occurred during those coldest winters. So this certainly is a bullish sign for a cold winter here, given the fact that the forecasted sea surface temperatures in the Pacific Ocean, both in the north and down in the tropical region of the Pacific, match very closely to the average of the coldest winters going back to the 1950s. Well, while Pacific Ocean sea surface temperatures are certainly an important factor, it's not the only factor to deal with when forecasting for the upcoming winter months. High latitude blocking is another important factor, and this has to do with the possibility of transporting cold air masses from the northern latitudes into the middle latitudes. We know during the winter months of January, February, March, there will be cold air masses up in the northern latitudes, places like Canada, Greenland, across the North Pole, in Siberia. Just by definition, because the sun is so weak in that part of the world, that time of the year, there will indeed be cold air masses. The question, however, is will there be upper level winds that will allow for the transportation of those models from the northern latitudes into the middle latitudes? High latitude blocking is a pattern that's related to the pressure pattern in the northern part of the world and the northern latitudes. Typically, with high latitude blocking, there's high pressure centered over places like Greenland. That in turn allows for the transportation of cold air masses from northern Canada, for example, into the northern part of the U.S. Meteorologists can track high latitude blocking through a couple of indices called the Arctic oscillation and North Atlantic oscillation. We'll talk about those in a moment. But high latitude blocking is an important factor, and we'll take a look now and see if that is a possibility for frequent occurrence during the upcoming winter months. Well, let's go back again to those coldest of winters that we've used before, going back to the 1950s, 15 winters here, to take a look and see if indeed they featured high latitude blocking. This is the 500 millibar, about the middle part of the atmosphere, 18,000 up, 18,000 feet or so up in the atmosphere. And again, this is the departure from normals for 500 millibar geopotential height. Notice this red area, orange area right over Greenland. This is basically indicative of high latitude blocking, high pressure centered over, abnormally high pressure centered over Greenland, and a trough here in the eastern U.S. So perhaps not too surprisingly, these winters, the great cold winters going back 60 years, did indeed feature high latitude blocking. So the fact that the Pacific sea surface temperatures in these coldest of years matches what we think will occur during the upcoming winter months is a bullish sign for high latitude blocking this winter. But there are other factors we'll talk about now and over the next few minutes. Well, in terms of high latitude blocking, not only may the Pacific Ocean sea surface temperatures play a role, but believe it or not, there have been studies that connect the sun to high latitude blocking situations in the wintertime. Specifically, low solar activity has been well correlated with frequent high latitude blocking patterns in the winter months. And here is actually the same kind of a map we just looked at, 500 millibar geopotential height anomaly chart for low sunspot activity years, basically low solar activity years. Most of these are occurred during solar minimums. And indeed, during these solar minimums or low solar activity time periods, there was an abundance of high latitude blocking. This is the average over these years with, again, Greenland, high pressure, abnormally high pressure centered over Greenland. And this too, believe it or not, is a bullish signal for high latitude blocking for this upcoming winter, because I believe low solar activity that is in existence today will continue right through the upcoming winter months. Now, these are mostly solar minimum years, and if you follow VencoreWeather.com periodically, we update the solar cycle number 24, the current solar cycle, which is actually currently in a solar maximum phase. So how could that be a period of low solar activity? As it turns out, this current solar maximum phase is one of the weakest in decades. In fact, it's on pace to become the weakest solar maximum in over 100 years. So the bottom line is solar activity has been low despite the fact that we're in a maximum phase for solar cycle 24, and that low solar activity should continue through the upcoming winter season, and that is a bullish sign for high latitude blocking. Well, here is in fact the very latest image of the sun, and there are a couple of sunspots regions right now visible on the sun, but all in all, this is an inactive period. It has been inactive despite the fact that it's a solar maximum phase, and it should continue to be a low solar activity period right through the winter season coming up 2014-2015. Well, not only does solar activity sometimes play a role in terms of whether or not high latitude patterns will set up, snowpack during the fall season has been correlated with whether or not high latitude blocking patterns will predominate in the subsequent winter months. This happens to be a chart from the end of September for the North American snow cover anomaly. And notice we were at very high levels at the end of September for North America as a whole. In fact, not only at high levels, but record high levels going all the way back to 1967. Some of you may recall a big snowstorm in the middle of September in Canada. Calgary, for example, was blitzed with a lot of snow. That certainly contributed to this. Very high snow levels at the end of September in North America as a whole. It's very important to look at cold air source regions during the fall season, Canada, Greenland, even across the North Pole in Siberia with respect to snow cover, because that's where the cold air masses will originate during the winter season. And indeed, this is a positive sign for deep cold air masses to develop during the fall season in those cold source regions. The fact that we were at record high levels across North America at the end of September. Well, some other studies have actually shown a specific connection between what happens in Siberia in October with respect to snow cover has a direct impact on the possibility of high latitude blocking. Specifically, if snow cover advances to the south, let's say south of the 60 degrees north line, in a methodical way during the month of October, that is a positive sign, a positive signal for high latitude blocking. And indeed, let's take a look at the first half of October, and all indications are that snowfall is going gangbusters in Siberia during the first half of October. Again, a positive sign for high latitude blocking, which in turn is a positive sign for cold and snowy weather in the eastern U.S. Here we go at the beginning part of October, and this is the snow cover extent on October 1st in this region of Siberia. Notice by October 8th, it expands to the south and west, and then by October 13th, just a couple of days ago, even farther to the south and west. The 60-degree latitude line is roughly about in this region right here. And again, the studies show that an expansion to the south and to the west in a methodical way during the month of October actually is correlated quite highly with high latitude blocking in the following winter months. If you're a snow lover, you don't want to see it barren in Siberia for the first 3 weeks of the month, and then all of a sudden a big blizzard dumps a lot of snow. You want to see a gradual buildup, because that allows for the gradual deepening of cold air masses in that all-important source region for cold air for the U.S., Siberia, on the other side of the pole. So amazing things going on in Siberia right now. Again, bode well for snow lovers here in the eastern part of the U.S. Well, we touched upon this earlier. One of the ways a meteorologist can track high latitude blocking is through an index called the Arctic Oscillation Index and its closely related cousin called the North Atlantic Oscillation. Basically, when these indices are in negative territory, that suggests high latitude blocking is in existence at that time or is forecasted to occur in a short period of time. In negative territory, that indicates high pressure in the all-important northern latitudes, places like Greenland, for example. It's not just high pressure, it's extended periods of high pressure that will allow for the transport of cold air masses, cold air, Arctic air outbreaks from northern Canada into the northern U.S., and that spills over into the eastern U.S. Well, indeed, one signal that occurred just a week or two ago, in fact, on October 9th, the Arctic Oscillation hit this -4 value. Here's the legend over here. It went into negative territory, the levels of which have not been seen in many, many years. In fact, you have to go back more than a decade to see levels this low in October. And in going back and visiting the winters going back 10 years or so, and all the winters with a value of -2, and keep in mind this year in October the value went down to -4, in those winters with AO plunging down to -2 in October, almost every single one of the following winters featured above normal snowfall with below normal temperatures. So this is definitely sending a signal that we can expect high latitude blocking to be a frequent pattern during the upcoming winter. That in turn favors cold and snowy conditions in the eastern part of the U.S. It bounced back briefly, but now is forecasted, which is indicated here by the reds, to go back down again, down to about -3 or so. Very impressive plunge in the Arctic oscillation during the month of October. Well, let's summarize. We've gone over a lot of factors over the past several minutes, specifically the Pacific Ocean, a warm pocket of water in the North Pacific, a centrally based weak to moderate El Nino in the tropical Pacific. We've talked about the fact that low solar activity usually favors the development of high latitude blocking, and excessive snowpack in the fall in the cold source regions of Canada, Greenland, and Siberia favor the development of high latitude blocking, especially the expansion southward during the month of October in Siberia. That is a bullish sign for high latitude blocking. And the Arctic Oscillation Index gave us a clue that high latitude blocking could play a predominant role in the upcoming winter months, which in turn leads to cold and snowy conditions in the eastern U.S. Bottom line, I expect colder than normal conditions in the mid-Atlantic region during the winter season, perhaps on the order of 1 to 3 inches below normal in the December to March time frame. Above normal snowfall in the mid-Atlantic region, probably on the order of more than 10 inches above normal, which ends up yielding 25 plus inches in DC, 30 plus inches in Philly, 35 plus inches in New York City. Colder than normal, likely throughout the eastern two-thirds of the nation, all the way down to the Gulf Coast, all the way out to the Rockies. Similar in some ways to last year. Warmer than normal in the western third, perhaps from Denver out to LA. They can have a warmer than normal winter. We'll continue to monitor all of these factors that we discussed here in this video over the next several weeks. That's it for now for the 2014-2015 Winter Outlook. I'm meteorologist Paul Dorian.